Hello, this is Mr. White, and this video is about composition of functions. I'm going to show you how to do composition of functions. We'll discuss more in class why we're doing it, how it's useful in real life. I'm going to start with an analogy here. Let's say here's some grass. We're going to call it X. And when you think of an animal that eats grass, maybe a cow comes to mind. So when the grass goes into the cow, we would call that C of X. And then I ask you to consider what is the cow's greatest natural predator. And you would probably say, of course, it's the elephant. So when the elephant comes along and eats the cow, what would we call that? Well, the cow is going into the elephant, so we would call that E of C of X. E for elephant, C for cow. And composition of function works like that. You take the grass, you don't put it directly into the elephant, you put it into the cow first, and then you put the cow into the elephant. With me? Notice that this is different. I would say that a cow eating an elephant is different than an elephant eating a cow. So this function over here, if the elephant ate the grass first, we would call that E of X. And then if the cow came along and ate the elephant, C of E of X. This is composition of functions. I should note that this is my favorite notation. I think this is the one that makes the most sense. But it is often written another way. This one on the left here is often written E of C of X. And that's really more of a little circle than an O, even though we say E of C. This one on the right, of course, would be written C circle E of X. And again, those are two different things, so we should make it clear that typically these will not be the same thing. Once in a while you may luck out and they may be equal to each other, but typically they're not. So notice that this is very different from function multiplication. Function multiplication is the main operation that students sometimes confuse composition with. Function multiplication is more like you have a cow, you have an elephant, and the grass not only goes into the cow, but the grass also goes into the elephant. So the same input goes into both animals, and that would look more like C of X over here, E of X, and then just a little dot for multiplication between them. So you can see how students might sometimes think that just because visually that looks kind of similar to C of X circle E of X, but we have to be clear, those are not the same thing. Composition in red, multiplication in black there. So that's the idea I want you to keep in mind. That's the analogy. As far as what this multiplication would produce, I don't know, maybe a cow-elephant. That's where my analogy starts to break down. So let's go to some actual examples here. Quick summary here. Again, I emphasize that you see that composition on the left here. This and this are the same thing. This and this are the same thing. And multiplication actually is a commutative. C times E does equal E times C, just like normal number multiplication. But again, none of these are equal to each other. Make sure that you observe none of these are equal to each other, neither of the compositions nor the multiplication. Okay, so let's look at an actual example. This is from the book. Let's say that f of x equals e to the x and g of x equals square root of x. And we're going to find the composition f of g of x. Let's do that first, and then we're going to look at g of f, and again, verify that they are not the same thing. So here's where I need you to really listen carefully, pause, rewind if you need to, because this is a really big point here. The way I would start this off is start off by looking at the, let me color code these. Let me say that f in green, G in blue there. And I'm going to start with the first function that's listed here, the f. So start by saying f, and I'm going to prompt you for this in class quite often. I'm going to say if f of x equals e to the x, then f of blank, and I'm going to expect you to say e to the blank. That's sort of a mindset that I want you to get used to. Remember, x is just a variable. I can put x here, and I've got my original function definition. But I can also put anything else inside those parentheses. So I could put a number here inside the parentheses. And that's how functions work, right? Well, turns out I can also just put an entire new function inside the parentheses. So in this case, I could put g of x as long as I also put it here. Now what we're going to find more useful, though, is I'm going to write another e to the blank here. And what we're going to find more useful is to write what g of x equals. So when we look at that g of x definition right there, I put g of x right here, but how about I put what g of x equals over here? Square root of x. Again, g of x equals square root of x, so I can do that substitution. If that is not clear, that was a huge step, really. If you got it, great, but if you don't, you really need to ask clarification, because that's something you need to know. So there it is. Can't really simplify that much. I suppose I could get rid of the parentheses, but can't really simplify much more than that. So that is f of g of x. And I'll remind you again, the way that the book has it written there, that's the same thing as f circle g of x. Okay? Let's do it the other way around. Let's do the g of f of x. Likewise, g of blank, I would prompt you in class, and you would say g of blank equals square root of blank, according to our initial definition up here. And we would fill that in with f of x. As long as I put f of x here, I can also put it over here. And then I would do my substitution. What does f of x equal? Well, it equals e to the x power. I won't put the parentheses here. They don't really do anything here. Now, the careless student might look at those two expressions or those two equations and think that this equals this. And we can kind of understand the mistake because they're the same elements in each problem. There's a square root sign and e into x. But we need to recognize that they are different. This one down here, let's take it a step further. Let's remind ourselves that a square root is the same as an exponent of 1/2. And remembering your exponential properties, if you multiply these two exponents, you get e to the x over 2. Okay, so reminder, that is the same as writing I'm sorry, that was a mistake, g circle f of x. That's an alternate way of writing it. They're both valid. And we see that this is definitely different from this. So I thought that was a good example in the book to show two that could be mistaken for being the same but are actually different. Let's do one more example before I have you try one on your own. And I also want to really just kind of hint at what function composition does for us. So here's an example you will not find in the book. I just made it up myself. I'm going to go ahead and honor my cow and my elephant by using the C and the E. And let's say that C of x, I'm going to color code it here in green. The E of x, I'll color code in blue. And we're first being asked to find E of C of x. So remember what to do. I'd encourage you to actively listen. If you want to pause and see if you can anticipate what I'm going to say, that's not a bad idea. We'll start with the outer function, right? We'll start with this E here. So E of blank. Notice that the x occurs a couple times in this E definition. So I'll put blank squared plus 3 times blank minus 1. I'm going to skip an intermediate step here. I'm going to put C of x here. And rather than writing C of x in the other two blanks, I'm going to go ahead and write what C of x equals. I'm going to go ahead and put the 2x plus 1. So hopefully you're with me on that. And in this case, we can go ahead, we can simplify this. So I'm going to do that pretty quickly. I'll remind you that it would be a big mistake to put something like this. I'm still seeing a number of students doing things like this. You cannot just distribute that exponent of 2. And in fact, it would still be a mistake, even if you thought the mistake was the parentheses. No, that's still a mistake. We need to remember that 2x plus 1 squared is like 2x plus 1, 2x plus 1. So we need to FOIL that out. And I'm going to go ahead and put 4x squared plus 4x plus 1. I hope you agree with me. Distribute the 3. Oops. I said to myself, distribute the 3 and get 6x plus 3 minus 1. Go ahead and combine our like terms. We get 4x squared plus 10x. 1 plus 3 minus 1 gives us plus 3. And that would be e of c of x. We're next asked to evaluate e of c of 2. So let's put e of c of 2. If I just substitute 2 in there, 4 times 2 squared plus 10 times 2 plus 3. That would be 16 plus 20 plus 3. That would be 39. Okay? I could call the problem done right there. I just want to point out one other thing. And again, while I'm going to wait till class time to get into more detail as to what function composition does for us, I'm going to hint at what it does. Let me just shrink this down a little bit. If we had done it another way, let me point out one other way we could have done it. I could have just focused on the, for that last part, e of c of 2, I could have focused first by what's c of 2. I could have said c of 2 equals 2x plus 1, or in this case 2 times 2 plus 1, which equals 5. And this is like plugging the cow into the elephant. I'm not going to plug that original 2 in. I'm going to plug in this result, this cow, as I'm calling it, of 5. So now I'm going to evaluate e not of 2, but of 5. And that would give me 5 squared plus 3 times 5 minus 1. 5 squared is 25, plus 3 times 5, 15. 25 plus 15 is 40, minus 1 is 39. So notice we got the same answer, but we had to do it in 2 steps. Again, that's a hint at what composition does for us, is that it took something that required 2 steps originally, or required 2 steps over here, and it does it over here in 1 step. You may think, okay, that 1 step took me just as long or longer, but if you were to do this operation, if you were to do e of c of x for many, many different values of x, I hope you would agree that it would be nice just to have a single equation for e of c of x. All right, so now your turn. You know the drill. Here's f of x, here's g of x. You're being asked to find f of g of x, and then f of g of 3. You're also being asked to find g of f of x, and then g of f of 3. Go ahead and pause the video, please. In just a moment, I'm going to reveal the answers you should get. Okay, here are the answers. I want to alert you to one possible mistake that I could envision students making. I could easily foresee some students at this first one, f of g of x, I could easily see some students trying to simplify that and saying that's 6 to the x minus 5. Please don't do that. That is not true. I'll remind you that if you wanted to get 6 to the x, this function would need to be 3 to the x times 2 to the x. That's what equals 6 to the x. But our 3 over here is not raised to the x power, so you cannot simplify that any further. Just leave it as is.